Hey everyone, Jules here of Dirt and Drone. Welcome back to my channel, and in today's video we are going to put the DJI Neo into the test with the DJI's O4 video transmission technology. This is the 4th generation of the OcuSync transmission by DJI's. So I am intrigued of how the O4 is going to improve the signal transmission of the video on their drones, especially on the FPV devices. So today we are heading out to our flying, I would call the flying ground. So this is the place where I normally flight my drones, FPVs, maiden flights. We are going to test the DJI Neo, as I've said, and I will be using the DJI's Goggle 3. So this is the Goggle 3, and paired with the FPV remote controller 3 as well. So we are going to use the DJI Neo as FPV drone today. Just a quick discussion about the O4, although it's not out in the market yet. It will be out maybe next year by February, I hope so we can get our hands on it. But do you know that the O4 transmission is already present on DJI's drones? These are the Mini 4 Pro, the Avatar 2, and the DJI Neo. That is why I want to test the DJI Neo today with the full potential of the O4 transmission protocol. The O4, the OcuSync 4, is significantly better compared to the O3. Why? It's because the O4 has a better signal transmission due to the addition of its 3rd frequency band. So O3 is a dual band, we all know that. But the O4, do you know that the O4 is a tri-band frequency transmission? So it adds the 5.1 frequency band to the present 2.4 and the 5.8. So that is good, because we already have 2.4 and 5.8, which is already, in my experience, is already good when it comes to FPV. But then, due to the more devices are using now these 2 common frequencies in the Wi-Fi environment, 2.4 and 5.8 is now becoming so crowded and dense, and it's now causing a lot of issues when it comes to transmissions and signal loss. So DJI realizes that they will add another frequency band into the mix, which is the 5.1 gigahertz. So in the O4, when you use the O4, the Goggle 3 with the Neo, you can actually use the manual selection of your frequency. You can either use 2.4 or you can use 5.8. So depending on how the area is suited for this kind of frequencies. And there's no option to choose 5.1 in the settings. The only way you can use 5.1 is when you use the auto switching or the auto frequency settings. So there are 3 settings that we are going to test today. we have to manually set it to 2.4, and we have to manually set it to 5.8, and then the last one is we are going to set it in auto frequency transmission. So on the third one in auto, that is when you can use the 5.1 gigahertz, because DJI's O4 transmission is utilizing they're using this, they call it frequency hopping. So frequency hopping is the system will detect the environment on how crowded is the frequency or the signal. So it automatically chooses the best frequency to be used in this kind of environment. So that is, it will choose 5.8 first. If the 5.8 is occupied or very crowded, then it will drop to 5.1, which is higher bitrate, but the transmission is not really good, but it has higher bitrate. If it's still not working well with 5.1, then it will go to 2.4, which is, we know that 2.4 is better when it comes to obstacles and rains. So yes, this is very exciting test. Actually, I am also excited to test this one on how it really works. So that what makes me excited on this DJI's OcuSync 4 technology, transmission technology to their drones and FPV, because I am really a fan of longer flights. Actually, my drones are built for longer range or mid to long range. I'm not really into longest range, but I call it like mid to long range. And when I see the specs, when I just hear the specs of the OcuSync 4, it tells me that it's really good to use for longer range due to the frequency hopping of these three frequency bands: the 2.4, the 5.1, and the 5.8. So yeah, let's going to test. Let us test the DJI Neo today. Here we are already here. We're going to fly our drone to a same route, using different frequencies. So we are here now. Let's go and let's do the test. Okay, so we have to set up our FPV gears. We have here the DJI Go 3. Let's switch it on. Let's switch it on. Then we have here the FPV Controller 3. Switch it on as well. And finally, we have the DJI Neo. Let's remove the gimbal protector first. And we're gonna switch it on. Let's put it here first. So first thing we have to do is we have to go to the settings and check the status. The DJI Neo is connected. We go to the transmission, and then here you can see the channel mode. It's still in auto. If you check that one, put that in manual. By the way, you have to do the FCC modification on this goggle before you can set these options into manual. So do the FCC hack first, and after you done that, then you can choose the frequency to manual. So here we go, choose manual. Let's try with the 5.8 first. Let's try with the 40 megahertz bandwidth. So we'll do the 40 megahertz test on this, and let's choose channel 1. So we will be using channel 1 on all the frequency for this one. So now that we are ready, and let's put the drone and here and to the top of the vehicle. So let's put it here. So after that, we're gonna put the drone into FPV mode, manual mode. And let's fly. So until the next video, guys, we'll be doing more tests on this DJI Neo with the OcuSync 4 transmission protocol installed on this drone. All right, so thank you very much, guys, for watching, and hope to see your comments down below on what can you say about this test with regards to the 2.4, the 5.8, and the OcuSync 4's tri-band frequency hopping using the 2.4, 5.1, and 5.8 GHz on this drone and the incoming O4 air unit. So thank you very much, and see you on the next video.